Hello everybody, this is Mr. Mayer, and in this video we will discuss reflectional symmetry. Now, remember, a figure has reflectional symmetry if there are one or more lines where the figure can be folded to have an exact match on both sides of the line. So your keywords here, for reflection or for a mirror image, your figure, your shape, can be folded and have an exact match on both sides of your line where you fold it. Okay, so let's take a look at a simple shape to start off with. We're going to look at a square. Now, we want to know, where is the reflectional symmetry of a square? Where do we have those lines? So you've looked at squares, you've done this for years. Where can we fold a square so that it lines directly up with itself on both halves? So let's say I want to find, where can I fold the square? Well, it's going to be halfway. So I want to draw maybe a vertical line halfway down. So I'm going to tell GeoGebra I want to find the middle point between these two. That's what it did. Found the middle point, or the midpoint. K is the midpoint of A, D. I'm going to do the exact same thing from E to F. And L is the midpoint from E to F. All right, so at this point, what I'm going to do is go ahead and connect them, make that line. I want to see, is this true? Is this line a true line of reflection? I tell GeoGebra to reflect it over line KL, and look what happened. A was on the left, now it is on the right. Now notice, all of my letters have an apostrophe next to them. If they have an apostrophe, this is called a prime. So this is called D prime. This is called A prime. E prime down here. A prime tells us that it is the new figure. This is called the image. So this was my original, and my image flipped. Everything flipped over that line. And notice, everything overlaps perfectly. It's beautiful. It overlaps exactly on top of itself. Therefore, this is a line of reflection. So far, we've had one line of reflection. Now, is it only a vertical line that I can use? No, actually, I can fold it side to side as well. So I'm going to connect K with L and tell GeoGebra that I want to flip it over this horizontal line, KL. Perfect. Look, I've got my primes. Don't worry about those ones. It's just a couple extra points we have. But I've got my primes here, and now D prime, F prime, E prime, A prime, they are in the reflected image of where they started. So far we have two, and Mr. Mayer, I am done. There are no more lines of reflection. There are no more reflectional symmetry. It's only two. Actually, that's not the case. For a square, this is specifically only for a square. If I look at my square, I can fold it side to side and up and down, but I actually can also fold it at a slant. A slant in geometry is called a diagonal. When I connect opposite corners to each other, this is called a diagonal. So if I go ahead and I draw my line, I'm going to go ahead and choose the entire figure again. And let's see, if I reflect it over this diagonal line, is A going to match with F? Let's try it out. Hey, perfect. It overlaps beautifully. So everything worked out here. Is that the only diagonal line I can draw? No. Go ahead and connect F with A this time, and it's perfect. So this is an exact overlap, and this is our fourth line of reflection. There are four lines to create reflectional symmetry for a square. Okay, Mr. Mayer, I think I have it. I think I understand that if it has four sides, then it's going to have four lines of reflectional symmetry. Is that correct? Unfortunately, that's not true. It depends on the shape. Notice what's special about a square. All the sides are the same, and all the angles are the same too. They're all 90 degrees. If I were to extend this and actually create a rectangle instead, if I do the exact same process and connect two opposite corners to make another diagonal, watch what happens when I choose the whole figure and I want to reflect it over this line again. Oh, wow. It's not overlapping exactly. There's extra stuff over here. Okay, so this is an excess to what the overlap was. And unfortunately, this is not a line. Look where D went. D went from top right to kind of like middle left. It's not all the way down to E. So that's what's wrong with a rectangle. It's only true for a square that it would have 4 lines of reflectional symmetry. The last figure I want to do with you, I want to review, is called a parallelogram. Parallelogram is super, super tricky. So that's why I want to go through it with you, make sure you understand it. So to go through a parallelogram, let's try it. Well, go through the exact same process. We did midpoint first last time. So let's find the midpoints between G and I. I'm going to find the midpoint, K. Perfect. Find the midpoint between H and J, L. Okay, but like they're not on top of each other, which ends up being fine. I mean, we'll try it anyway. So if I connect K with L, if I go ahead and fold this side over, is it going to be a perfect match? Start making your guesses. Start making your educated guesses or your hypotheses. If I were to fold this and decide, I'm going to choose the entire shape again, tell it to reflect over this line KL. Oh, wow. That's totally not right. So this part's overlapping. That's why it's a little darker. But all of these are the extra pieces. It didn't go correctly. Look where it did. Look what it did. It went from I was top right, and look where I moved. It's like weirdly here. So, I mean, that's nice, but now I've got all this, like this J. Wow, that totally didn't line up. Here's the kind of the shortcut. Here's the clue. When you are trying to reflect, the short, fast way to do it is to draw a straight line or a 90-degree angle to your line of reflection. Notice from G to G prime, the old one to the new one, it's a straight line. G hits this line at a 90-degree angle. So that's something to keep in mind. So, well, Mr. Mayor, let's maybe instead go ahead and try to line this up with a point directly underneath and see what that does. I'm going to go ahead and make a line through K so that it's perfectly vertical. So now I went ahead and made it, and look, if I flip it over this line, oh, this is going to be super short down here. This is super long. There's no way it's going to match up. Just to double check and make sure, if I choose the whole figure and I reflect, yo, definitely not lining up. All right, so that didn't work. It's going to be the exact same thing if I do a horizontal line. So one last chance. I've got no lines of reflection yet to make reflectional symmetry. Maybe I'll go ahead and do the opposite corners like I did in that square. If I connect G to J, if I connect G with J, I'm going to go ahead. Let's see what happens. I mean, I with H, I mean, they're both obtuse. They're both big angles. So hopefully they'll go ahead and land on top of each other. But as I tell it to go ahead and flip over this, it's not a perfect overlap. So unfortunately, our parallelogram has no lines of reflection. The best way to help you out with this is to actually take a piece of paper, ladies and gentlemen, go ahead and start folding it. Draw your shape, cut it out, and fold it. That's going to help you visualize. You'll start to learn GeoGebra throughout the course, and that will definitely help you out as well. Thank you for tuning in, and looking forward to seeing you in the next video.